Alright, so we're back on the hydrogen kick. Found another video of Toyota's CEO talking about the hydrogen car and how it's going to affect the EVs. Been doing a little bit more research and digging. There's a bunch of information and videos on hydrogen fuel cells. That's not what I'm interested in. We want to work on the hydrogen engines, how to produce hydrogen from water to make an engine run. Now, I've done a little bit more research on my side. I was digging into the 78 Camaro that was run on water that I can't find any information on now. Trying to remember what was going on. I mentioned before in a previous video how the government said it was a nuclear device and you couldn't do that. So I started Googling around a little bit. In order to split a water molecule, it takes 1.23 volts DC. That's in between a cathode and an anode, which would be two metal plates, a negative and a positive DC plug. 1.23 volts to split that. Now, for AC voltage to split a water molecule, it's a little bit different. Now we're talking about nuclear fission, and all kinds of red flags and bells and whistles go off. Now, because you put the word in nuclear in front of anything, people start to freak out. It's a definition. By definition, when you split a molecule, it's nuclear fission. When you take AC voltage, 6.9 kV, to split a water molecule, it will split them, two hydrogen, one oxygen, and then you double spark that. You get the split, you get the spark, you get the fire, you've got a running engine. So basically, you make a stutter spark in the engine, and you can have this work. But because it is a nuclear device, red flags go off, and that's a big no-no. So, by definition, the general public is not supposed to have access to this kind of stuff, I guess. I'm not 100% sure. Let me know in the comments below how this stuff works. Because we're not creating bombs. We're not creating any kind of strange power plants. We're doing something really simple that's been done for a long time. We are splitting a water molecule into hydrogen and oxygen. You can do it with 1.23 volts DC. That's a AA battery. We'll split a water molecule. That minuscule of an amount. People say it takes more energy to split a molecule and produce hydrogen than the hydrogen will produce after the splitting of the molecules. Really? Are you sure about that? Low voltage systems? Yes. But I've also learned that a 6-volt battery is only going to produce so much of a froth. You hook it to a 20-volt drill battery, you create a bigger froth. You hook it to 48 volts DC, you've got a massive amount of hydrogen being created. 48 volts. So, voltage is key. Not amperage, not wattage, voltage. This is what I've personally found. Now, let's see what these guys have to say and what Toyota's got going on with their new hydrogen-powered engine. Because the last information that I saw on this, they were looking for a hydrogen cell that created a short feed of hydrogen to run an engine. There's a brilliant design. It is not technically shooting water into an engine and firing it like I'm talking about, but it's close. It's really close. It's the whole cheese ball thing. You get a nice soft container, you produce enough hydrogen, you plumb the hose into your air intake on your car, it will start, it will run. People have already taken a 10 mile per gallon pickup truck, taken a couple of Gatorade bottles with a couple of pieces of steel plate in them, created hydrogen converters, HHO converters, run the hose to their intake, on their engine, changed the timing a little bit. That's a key piece. Changed the timing a little bit, and they've gotten double, triple, quadruple the fuel economy out of it by adding a little bit of hydrogen. Imagine the little amount of hydrogen more it's going to take to completely run a gasoline engine off of 100% water. It's not that much.
Toyota has been working on developing a hydrogen-powered engine for years. The company believes that hydrogen is the future of clean and sustainable mobility, and that hydrogen engines can offer the fun of driving, including through sounds and vibrations, while emitting zero CO2. Now, Toyota has reached a very advanced stage in this pursuit. The company has just revealed its new hydrogen-powered engine and a concept vehicle that could be production-ready soon. Toyota claims that this engine can deliver high performance and responsiveness, as well as reduce the cost and complexity of fuel cell systems. Join us as we take a look at Toyota's new V8 hydrogen engine that will change everything. Everyone knows that Toyota has its reservations in regards to an all-electric future. As the Wall Street Journal reports, former CEO and current chairman Akio Toyoda said, "People involved in the auto industry are largely a silent majority. That silent majority is wondering whether EVs are really okay to have as a single option. But they think it's the trend, so they can't speak out loudly. Because the right answer is still unclear, we shouldn't limit ourselves to just one option." While this perspective is very controversial, it's worth thinking about. All-electric cars make up only a small part of the overall new car market, which means there's room for different types of vehicles. Toyota has decided to pursue the path of hydrogen combustion engines. Toyota has now introduced the Corolla Cross H2 concept, and it is likely to come to market in the next few years. The Corolla Cross H2 concept is a compact crossover that uses a modified version of the 1.6-liter turbocharged three-cylinder engine that powers the high-performance GR Corolla and GR Yaris models. However, instead of running on gasoline, the engine has been adapted to burn hydrogen as a fuel, which produces only water as a byproduct. This makes the Corolla Cross H2 concept a zero-emission vehicle that can offer the same driving experience and performance as a conventional internal combustion engine car. To achieve this feat, Toyota has applied some of the hydrogen technology that it developed for its FCEV, fuel cell electric vehicle, the Mirai, which uses a fuel cell to convert hydrogen into electricity. The Corolla Cross H2 concept features thick armored fuel tanks that can store hydrogen at high pressure and safely withstand impacts and collisions. The engine also has some modifications to handle the different properties of hydrogen gas, such as hardened valves and valve seats, stronger connecting rods, and specially designed fuel injectors that can spray hydrogen into the cylinders. The Corolla...
All right, I made mention of the internal components needing to be changed and the technology already being there. They're talking about hardened seats and hardened valves. We can just go to titanium and skip the middleman. I mean, we even run stainless ones and still skip the hardening part. Motorcycle industries already showed that titanium and stainless valves are viable options, and for high performance engines they work out really, really well. They're a little bit more on the maintenance, but hardened steel valves wear out a lot faster than stainless or titanium valves do, at least in the motorcycle industry. And we're talking F1 style pancake pistons in the 450 race quads, not the big 4x4 monstrosities that I don't like. If you guys see the typical content that I put out, we build race quads, we build race trikes, 450s, 252 strokes, 4 strokes, race stuff. Make it go fast, high performance, fuel injected, all that fun kind of stuff. These guys, I did run into another video I may blend into this one, explaining the faults behind the hydrogen engine. And from the beginning of it, it didn't really seem like there was a whole lot of faults behind it, but dude was getting really, really scientific fast, and I got bored. So we'll see what this one keeps going. We've got, let's see, we're not even 3 minutes into a 9-minute video, so let's keep going here. See what they got to say. I am kind of interested in the hydrogen EV, though, with the hydrogen fuel cell charging the batteries. That's kind of neat. It takes a lot less to charge a battery than run a vehicle. Smart.
H2 concept is not only an eco-friendly vehicle, but also a practical and spacious one. Like a standard Corolla, it has room for 5 passengers and their luggage, and offers a comfortable and smooth ride. Also, in exciting news to gearheads everywhere, Toyota and Yamaha Motor have joined forces to develop a groundbreaking hydrogen-powered V8 engine that could revolutionize the automotive industry. The engine is based.
Yamaha is the only manufacturer at this point in time still building a 450 race quad. They are the only manufacturer still using the F1 technology, the pancake pistons, and the titanium valves in high-performance race engines. Honda, Suzuki, Kawasaki have all dropped it. So Yamaha is definitely the brand to go with if you're going to team up and you need performance. I'd said something about Honda being a big one because of their F1 engine plans. Yes, but Honda's also kind of fallen off to the wayside with certain things because they're not continuing up with the off-road racing. They've gone more to the side-by-sides and the monster quads, and they've left the quad racing to the side. The CRF 450s are still monster dirt bikes. That technology's still there, so I mean it's still in the off-road world, it's just not the quad world. Dirt bike technology is still pushing hard and the engines are crazy. But in this instance, I still see Yamaha as an extremely viable and logical choice to team up with when it comes to high performance tech.
A 5-liter V8 that powers the Lexus RC Coupe, a luxury sports car that offers a smooth and exhilarating ride. However, the new hydrogen V8 has some significant modifications that make it more eco-friendly and efficient, while still delivering a high level of performance. The engine uses hydrogen as a fuel, which is stored in pressurized tanks and injected into the cylinders, where it is ignited by spark plugs. The combustion of hydrogen produces only water vapor as a byproduct, making the engine a zero-emission vehicle that does not contribute to air pollution or global warming. The engine also has some changes to the cylinder heads and fuel injectors, which are designed to handle the different properties of hydrogen gas, such as its higher octane rating and lower density. The hydrogen V8 boasts an impressive output of 455 horsepower at 6,800 revolutions per minute and 398 pound-feet of torque at 3,600 revolutions per minute, which is...
That's good numbers. Holy crap. People were saying hydrogen motors are weak. That doesn't sound too weak to me.
Lower than the original gasoline V8, but still enough to provide a thrilling driving experience. The engine also has a unique feature that sets it apart from other engines, an 8-into-1 top-mounted exhaust manifold, which collects the exhaust gases from all 8 cylinders and directs them to a single outlet. This design creates a distinctive high-frequency sound that Yamaha claims is similar to the sound of a Formula One car. The hydrogen V8 engine is still in the development stage, but Toyota and Yamaha hope to showcase it in a prototype vehicle soon. The engine could be a game-changer for the automotive industry, as it offers a viable alternative to gasoline and electric vehicles that can combine performance, efficiency, and environmental friendliness. So, what exactly are hydrogen engines so special? One of the advantages of hydrogen-powered cars is that they are very easy to refuel, and they do not require a lot of time to do so. This is because hydrogen is a gas, not a liquid, and it can be pumped into the car's tank much faster than liquid fuels. If you have ever filled a propane tank for your barbecue or camping stove, you know how quickly the process can be done. You just need to connect the nozzle to the tank, open the valve, and wait for a few seconds until the tank is full. The same principle applies to hydrogen-powered cars, but with even more speed and convenience.
No. See, this is the problematic part. They're using tanks to store it. This is pressurized hydrogen. These tanks, as people have made mention of in the past, these tanks can be problematic. They need to be inspected. They need to be maintained. Yeah, it's a neat idea, but no. We need on-demand hydrogen, a small little device that creates what we need. That no, 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 no.
Toyota Yaris GRH2.
It makes a little more sense why the horsepower and the torque were a little bit weird and stuff, because it's going off of pressurized hydrogen. So I mean, yeah, you're getting the pressure you need to run the engine, but no, they're still stuck in the same box as the gas and diesel engines. They didn't come out far enough. They didn't come out of the box far enough. They just added a different fuel source, which is a start. They just need to figure out how to create that fuel source from water, not a pressurized hydrogen canister that you plug into the side of your car. That's, you talk about a bad time to leak. Boy.
Which is a compact hatchback that runs on hydrogen, only takes a minute and a half to fill its tank completely with hydrogen. That means you can spend less time at the gas station. Would take much longer, depending on the size of the tank and the flow rate of the pump. Hydrogen-powered cars are not only eco-friendly and efficient, but also practical and user-friendly. They offer a similar driving experience as conventional cars, but with less hassle and more convenience. Filling up a hydrogen-powered car is just as easy as filling up a propane tank, but much faster than filling up a gasoline car. Also, hydrogen has a broad climate adaptivity. Diesel fuel has been a popular choice for vehicles that need to carry heavy loads or tow large trailers, as it offers more torque and better fuel economy than gasoline. However, diesel fuel has a drawback. It can gel or solidify in extremely cold regions, where the temperatures can drop below 0 degrees Fahrenheit. This can cause problems for the engine, such as clogging the fuel filter, reducing the fuel flow, or damaging the fuel pump. To prevent this, drivers need to use additives or heaters to keep the diesel fuel from freezing. Unleaded fuel, which is the most common type of gasoline used in vehicles, does not have this problem. Unleaded fuel can withstand temperatures as low as -100 degrees Fahrenheit, which is much lower than the freezing point of water. This means that unleaded fuel can work well in regions that experience severe wind chill, which can make the air feel much colder than it actually is. Unleaded fuel also has some advantages over diesel fuel, such as producing less emissions and being cheaper and more widely available. Lithium batteries are more resilient than other types of batteries, as they can operate in a wide range of temperatures. Lithium batteries can withstand temperatures as low as -140 degrees Fahrenheit before they start to lose their capacity or efficiency. However, lithium
yeah, that's not what this winter showed us. That's not what this winter showed us at all. This winter showed us that lithium batteries, or at least the batteries they put in the cars, are faulty in cold. Because people had no go in the cold.
are not immune to freezing issues, as they can still suffer from reduced performance or damage if they are exposed to extremely low temperatures for a long time. To avoid this, drivers need to keep their lithium batteries warm or insulated when not in use. Hydrogen, on the other hand, is the most versatile and adaptable type of fuel for vehicles, as it can handle temperatures as frigid as -435 degrees Fahrenheit, which is close to absolute zero. Hydrogen is a gas that can be stored in pressurized tanks and burned in internal combustion engines or converted into electricity in fuel cells. Hydrogen does not freeze or gel like diesel fuel, nor does it lose its capacity or efficiency like lithium batteries. Hydrogen also produces only water vapor as a byproduct, making it a zero-emission and eco-friendly fuel. The same principle applies when considering extreme heat. Hydrogen exhibits superior adaptability to a wide range of climates compared to the other two available options. Diesel fuel and unleaded fuel can evaporate or ignite in high temperatures, causing safety hazards or performance issues. Lithium batteries can overheat or catch fire in high temperatures, causing damage or explosion. Hydrogen, however, can withstand temperatures as high as 5,432 degrees Fahrenheit, which is the surface temperature of the sun. Hydrogen does not evaporate or ignite easily, nor does it overheat or catch fire. Hydrogen can also cool down quickly after being used, making it more efficient and reliable. Therefore, hydrogen is the most suitable choice for extreme cold and hot climates worldwide, as it offers superior adaptability and versatility compared to diesel fuel of the sun. Hydrogen does not evaporate or ignite easily, nor does it overheat or catch fire. Hydrogen can also cool down quickly after being used, making it more efficient and reliable. Therefore, hydrogen is the most suitable choice for extreme cold and hot climates worldwide, as it offers superior adaptability and versatility.
What are they considering ignite easily? I guess they said it had a higher octane, so yeah, higher octane is less likely to combust. But spark's a spark. Make go boom. Okay.
Compared to diesel fuel, electric vehicles can't give you that experience, but a hydrogen-powered car can because it operates in a similar way.
Rumba.
What do you think about this? Let us know in the comments section below.
This dude here on Engineering Explained explains a little bit more about the efficiency of a hydrogen engine versus a gasoline engine, but we're not talking a hydrogen converter again. We're not talking water fission. We're just talking pressurized hydrogen in a hydrogen fuel cell vehicle. While this is an interesting topic, we really want to find the hydrogen converters for the on-demand hydrogen to make these things run.
Hello everyone and welcome. In this video I'm going to use this 5-gallon bucket with an American flag on it to make you sad about V8 engines. But first, let's start off with some good news. Yamaha, with the help of Toyota, has developed a hydrogen-powered V8 engine. Look at it. Look at that ridiculous exhaust. It is glorious, and it has no carbon emissions. A clean V8 engine. What is not to love? So this engine has been developed using the 5-liter V8 engine from the Lexus RCF and then modifying it to run on hydrogen. And as you can see, looking at the horsepower and torque, it's actually very similar in numbers to the Lexus RCF. So very similar to the gasoline engine, except now we're only using hydrogen as our fuel source, meaning our emissions are water, and we don't have to worry about carbon emissions at all, a clean V8 engine. So in order to understand the problem here and get to our 5-gallon buckets, let's first compare the Lexus RCF to existing hydrogen-powered vehicles. So we're going to use the Toyota Mirai, which uses a fuel cell in order to power itself. So the Toyota Mirai does have significantly less power and less torque. That's fine. We're not going to worry about that yet. Our Lexus RCF has a fuel tank of 17.4 gallons, and it gets a combined rating of 19 miles per gallon, giving it a range of about 330 miles, and it has a trunk of 10.1 cubic feet. We'll get into why that trunk size is important in a moment. The Toyota Mirai has 5.6 kilograms.
It's not even getting 20 miles to the gallon? I understand this is from a year ago, which is funny because the first video that we watched was from a couple of months ago. This video is from a year ago. It makes me wonder how long the hydrogen engine's been out.
Of hydrogen stored on board. This is basically how we measure how much hydrogen you store in a vehicle, because it's stored as a compressed gas rather than a liquid that you can simply measure in gallons. So we have 5.6 kilograms of hydrogen. That is within 142.2 liters of hydrogen storage tanks. There's actually 3 tanks in the Toyota Mirai. And it gets a combined MPGe rating of 65. So that gives it a range of about 357 miles, and it has a 9.6 cubic foot trunk. So as we look at these, both of these technologies exist today. Obviously, both of these technologies work. All right, let's dive straight into the problem. So let's assume we're going to create a Lexus RCF that instead of running on gasoline, it runs on hydrogen. So instead of putting gasoline in that 17.4 gallon tank, we're going to fill it with hydrogen. Now, the problem here is that hydrogen is at 10,000 psi, but let's just assume we can safely use this 17.4 gallon tank and fill it with this hydrogen at 10,000 psi because we have that space available to use. So we have that about 17.5 gallons, about 66 liters, and we want to figure out how much hydrogen can we store within this fuel tank. So if we look at our Toyota Mirai, we know that we have 5.6 kilograms of hydrogen within 142.2 liters. So if we take that 5.6 divided by 142.2, that tells us how many kilograms of hydrogen we have per liter, which is about 0.04. Now, if we have 66 liters of available space to store that hydrogen, well, that tells us we have 2.6 kilograms of hydrogen available to use. Okay, so we know how much hydrogen we have, but how far can that take us? So an interesting thing about hydrogen is its energy content. So 1 kilogram of hydrogen has about 33.3 kilowatt hours worth of energy in it. Now, 1 gallon of gasoline has about 33.7 kilowatt hours of energy in it. It is a rare example of metric and American units just having this beautiful compatibility here, where 1 gallon of gas is the energy equivalency of about 1 kilogram of hydrogen. Okay, on top of that,
that's
hydrogen
interesting.
is also roughly equal in efficiency when used in a combustion engine as gasoline. Current studies show that it's slightly less efficient, but theoretically they have similar potentials as far as efficiency is concerned. So knowing that, and because we know our Lexus RCF gets 19 miles per gallon, and a gallon is roughly equivalent to a kilogram.
I'm really curious into the less efficient part of this, because as volatile as a hydrogen spark is, I'm wondering if they're making the numbers lower to make it look like it's a less viable asset because of how earth-shattering and global changing this tech can be. Hydrogen power sources, hydrogen fuel cells, hydrogen converters, it's a very viable power source, very easily made, very easily maintained if you don't overcomplicate. Now with these high pressure 10,000 psi tanks that are in these hydrogen fuel cell vehicles now, it's a little bit different than the hydrogen converters, but as he's showing, kilogram versus gallon is pretty equal. Horsepower is pretty equal. Everything's pretty equal. So if it's only a little bit less than and a lot better for the environment, why are we not pushing this tech? Big Oil might have something to say about that.
And they have similar efficiencies, well, that means that this Lexus RCF powered by hydrogen is going to get 19 miles per kilogram. And 19 times 2.6 means our hydrogen Lexus RCF has a range of only 50 miles. And that is at the EPA rating, so meaning driving relatively lightly. You know, if you're going to actually put your foot down and have some fun, you could easily cut that in half and only have 25 miles of range. So when it comes to range, the number everyone loves to talk about is 300 miles. We want our cars to be able to travel 300 miles without stopping. That's what we're used to with our gasoline cars. So electric cars, hydrogen cars, whatever it is, it needs to hit 300 miles. So let's look, using these buckets as a visual, how much space is required in order to store enough hydrogen to have a V8 powered vehicle travel 300 miles. So each one of these is 5 gallons. We just calculated that with 17.5 gallons, in other words 3.5 of these buckets, we can travel 50 miles. So if we multiply that by 6, we get 300 miles. So 3.5 of these buckets times 6 gives us 21 buckets.
Wow.
Okay, so let's see how much space 21 of these buckets takes up. And keep in mind, we are putting these inside of a hatchback with the rear seats folded down. In other words, a vehicle that has a lot of storage space. This isn't a sports car with not a lot of space to store fuel or cargo. And yes, I did verify that these are in fact 5-gallon buckets. They are just slightly larger, but it's not enough that it dramatically affects the purpose of this demonstration. Keep in mind that the actual storage vessels are going to be bulkier than this in order to compensate for the extremely high pressure of the hydrogen inside.
Wow.
Okay, so show me a sports car that you can fit this many 5-gallon buckets in. It doesn't work. But you might say, Jason, this is disingenuous, right? The storage tanks aren't a bunch of individual buckets. Certainly you'd put it in a more efficient shape, right? Okay, hold that thought.
Yeah.
Beautifully branded. Okay, so show me a sports car that you can fit this inside of. And keep in mind, this is going to be at 10,000 PSI. So wherever it's located, it needs to be sure that in the event of a car crash, it's going to be kept safe. Oh, and this is 95 gallons, so we still need 2 more of these in order to get to 105 in order to have that 300-mile range. So if we calculate the volume required in order to store enough hydrogen for this Lexus RCF to travel 300 miles, it is 14.1 cubic feet, which as you can see is larger than the entire trunk of the RCF. And that's not even considering that it needs to be a pressure vessel that's holding all this hydrogen. There's not even enough space in the trunk to do it, and then you don't even have a trunk. Now, to further demonstrate how silly this is, let's analyze an electric car and talk about how much volume it needs to travel 300 miles. So we can do that by looking at an individual battery module. At this point, this is dated technology. This is from the Tesla Model S, and so we have about 16 liters required for one of these modules, which gives you 5.2 kilowatt hours. So you can do the math and find out that you need about...
This is really interesting information. So the technology's there. Fuel efficiency is kind of there. Storage is a little on the complicated side. But this is for the pressure vessels. It's close. At least they've got the engines to run them. Now we need to get the converters to make it so that all we need is a gas tank of water. I still really think, and I'm still really going to try and find more information on the water fission car, because that's key. If we can get a water fission engine, then we've got power. And then, as they showed, collecting the water in the cup from the exhaust, they're not running, well, they're running pressurized hydrogen gas. So they're not running water. If you take regular distilled water, you put it in a gas tank or a water tank in this situation, and you put that over the hydrogen converter, and it converts that water into a hydrogen oxygen gas, which gets put into the engine, fired. You run the exhaust, you loop it through a water box where it can collect the existing water. The ambient air that was taken in through the intake pulse will get shot right back out the exhaust. The water that was taken and the hydrogen that was taken from as the fuel to burn will get recycled, and you can take that water box and feed it right back into your tank, pretty much making a massive boost in your fuel economy because you're recycling the fuel that you're using. That's opportune right there. You're able to recycle and reclaim what you just used. Maybe not all of it, but if you can recycle most of it, or even half of it, if you got a 20-gallon tank, that's an extra 10 gallons. The numbers are there. Is it viable? Yes. Is it plausible? Yes. Has it been done? Yes. Have they shut the people up that have done it? Yes. That's why it's not out there. I know this is typically an off-road channel. You want to see the builds and stuff that are going on? Videos are down there. We're uploading the build videos, ride videos. Didn't make it to the races today. Had to finish up Williams Lifted Big Red. That thing's ready to go home pretty much. We'll have a video on that one. Actually, there's a couple of videos up on the page already of it. I'll get a video of it running around, showing how it's working now. It is steering a lot better, handles quite a bit better. And so I want to do reactions on something that's a little bit off topic, but still in the automotive and engine gearhead kind of niche. Three-wheelers and race quads only go so far. Can only do so much. This is an ever-evolving shop. Granted, the shop work is three-wheelers and race quads so that we can keep a race shop. Content, on the other hand, we can have as much fun with it as we want. Right now, I kind of like the idea of the hydrogen stuff, so we're going to play with the hydrogen stuff. It gets views, gets you guys to watch it, you react, you comment, you like. Really chasing watch hours at this point so we can get monetized. When we get monetized, we can start putting back into the channel, not just feeding the channel off of pennies. Once we start putting back into the channel, the shop will grow, things will improve, everything will get better. We're at the bottom now. We're climbing towards the top. We'll see y'all there. Y'all have a great day.